The broadcast is now starting, and all attendees are in a listen-only mode. For your information, this session will be recorded, and the recording may be made available to others. The participants list in this private mode is in private mode so that other participants cannot see your name. However, your name will be displayed in the chat window if you use the chat function. If you want to stay anonymous, send your chat message to the moderator only, please. If you do not wish to continue based on the above, please log out. Ladies and gentlemen, good day and welcome to today's mindsON Centralized Statistical Monitoring Workshop, an initiative by Centegrity's myRBQM Academy. Today, we speak about how to work with Centralized Statistical Monitoring tool. I'm Tamara, the Operations Manager of the myRBQM Academy at Centegrity. Welcome, everybody. So our mindsON session today will run for approximately 1 hour. It will be an interactive workshop that includes polls, brainstorms with hopefully action from your side, and questions and answer sessions with our speakers at the end. So feel free to submit questions and comments for our speakers throughout the workshop using the chat box, which you see on the right side, and I will moderate your questions. Okay, about our speakers. Dr. Johann Pröwe, besides being a much sought-after industry speaker, Johann brings data-driven realism to the table, ensuring that clinical trial risk management goals are implementable in the real world. Johann has a considerable depth of experience in clinical research, which has been invaluable to many. Ting-Yu Ho, our clinical scientist from R&D department. Ting-Yu is one of our smart brains behind developing the myRBQM portal's risk recommendation systems and pre-processing our clients' clinical study data. Ting-Yu will engage you with an insightful demo of the myRBQM CSM tool. Okay, and before we continue here, before we even start with the webinar, I would like to show you the tools that are available for you here because, as already said, this is an interactive session. Later on, I will unlock a toolbar for you for the brainstorming part that we have prepared. You will see there a little icon with a cup and pens. When you click on that, just click on the T box to open the text field. There you can pick a color and you can start writing. Your entries are anonymous then, so please don't be shy and brainstorm with us when it is time. Okay, now I would say it's time to start. So have fun, please. And I would like to hand over the stage to you, Johann.
Thank you very much, Tamara, and welcome everybody. I hope that the audio problems that one of the participants had could be resolved by now. What Ting-Yu and I want to do today with you is that we take a closer look at what is the centralized statistical monitoring, and in particular also compare that versus risk-based quality management in the classic sense, because I think we need to distinguish between these two aspects of running risk-based quality management. So I have a brief definition here on this first slide about what is centralized statistical monitoring. And it is a way to look at data to detect any abnormalities or anomalies and risks that were unexpected and unlikely detected via key risk indicators. So I think this is already the very first important aspect when working with key risk indicators, and I have another slide on that topic. When working with key risk indicators, you as a user first have to think about what is it that can go wrong in my study. But of course, when you start thinking about it, it could be really 625 different things that could go wrong, and you cannot implement 625 different key risk indicators. Luckily enough, there are the centralized statistical monitoring tools available that would help a customer to look at the other data that are not covered by the key risk indicators and make sure that those data and potential anomalies in those data could also be detected without planning key risk indicators. So what we also would like to address is what type of data are needed for such an analysis and what is it one can expect to detect. So we'll dig a little deeper into the requirements on one hand and also the output on the other hand. Is it only outliers, or can centralized statistical monitoring deliver more? Because we sometimes get the questions, yeah, outliers is quite good and fine, but we would be interested in additional anomalies in the data that are not necessarily based on outliers, and we'll address that in this presentation. And of course, what are the appropriate steps to take once abnormal data have been detected? So this is very similar to the key risk indicator situation where a threshold is being exceeded, but then all of a sudden, like in this case, you see abnormal data, anomalies in the data. What is it that you do then with those findings that you have? And then we will demonstrate what such a centralized statistical monitoring functionality can provide to the study data quality and the patient safety. So what is it really that we see in our day-to-day life and that one can then use also for his or her study? So this is sort of the agenda, a workshop overview, the difference between RBQM and centralized statistical monitoring, how to approach the usage of CSM, CSM results examples. So we have a whole bunch of different examples that Ting Yu cranked out of various databases, and actions to be taken based on the centralized statistical monitoring findings. And then we have a couple of minutes hopefully left for questions and answers. So what's the difference between RBQM and centralized statistical monitoring? Those of you that attended other Syntegrity webinars, you already know this part here in the middle where we discussed let me just take the pointer, I think this is much nicer, where we identified the critical data and the critical processes as the first step of a risk-based quality management process. Then we did the risk assessment. We looked for the risk identification, assessed the study, the protocol mainly, and we quantified or scored the risks. Then in the second step, we looked into the risk mitigation and control, the actions to be taken to reduce the risk, so the so-called mitigation actions. Then defining the key risk indicators, and that is what I was talking about in the previous slide, define the key risk indicators and to set the tolerance limits. So it's certain thresholds that come along with the metrics, and then that defines the key risk indicators. And one has to develop an issue mitigation plan. And eventually, during the conduct of the study, the central monitor has to monitor the key risk indicators for any potential issues and manage the events and the conditions, and eventually, archive the risk management results, feed that back into the next study, and hopefully run a better study the next time. What you see here on the right-hand side is the various adjacent tools or applications that might be of interest. So for instance, a risk mitigation and actions database or ad hoc reporting might be of interest, or a probabilities database for predictive analytics, and of course, everything related to reporting, including the audit trail, etc. So what Ting Yu and I are going to focus on today is this aspect here, the centralized statistical monitoring. So that I hope puts everything into perspective with respect to what is the regular, this sort of more or less standard risk-based quality management tool, and on the right-hand side, the additional tools and functionality, and our focus will be on this centralized statistical monitoring. Tamara, if there are any questions that you want me to address, then please feel free to interrupt me, okay?
Yes, of course. Thanks very much. So far,
Okay,
there is no question from the audience.
okay,
But dear participants, if there is anything like Johan just said, put your question in the chat window, please. And I make sure it gets addressed.
okay, appreciate it. Thank you. Okay, so before we get started, I would like to run a little poll with you and hand it over to Tamara. And let's see.
All right. We have a question for you, please. Did you start implementing CSM yet? So let us know, please. Maybe yes for all studies, just for a couple of studies, perhaps, or just for a pilot study. Some of you may say not yet, but it's in planning, or no, not at all. Just let us know what is your stage, please. Thank you very much. And I see the answers are coming in. That's great. Just giving another couple of seconds to answer the question here. Okay. So let me present the results now. And Johan, I hope you see it.
Not yet.
That is weird. Something is wrong here. Just a moment.
But I pretty much recall what I saw.
Yeah. For whatever reason, I had no choice, no chance at all
So
to
this is the test.
present. So I guess we have to start all over again. I'm very sorry for this inconvenience. If you could just make your choice one more time. The technique sometimes. Okay, that looks good. Present results. So
Oh,
okay.
can everybody see the results
Yes.
already? Okay, so if that is the case, of course, we all want to be eventually in the purple area. So I cannot show that. In the purple area, so response A, yes for all studies. But I see that the majority of the participants uh, plan to implement centralized statistical monitoring, but did not do yet. So maybe this is a webinar to prepare you for the implementation of centralized statistical monitoring. We have also about 30% of the participants that already implemented the centralized statistical monitoring for the first couple of studies, and a minority just for a pilot study. I did not see any response E, which means no and do not plan to implement. So I'm glad to see that, but I'm pretty sure this is a biased view because it's a biased group of people that attend this webinar. So why should someone participate in this webinar who is not planning to implement centralized statistical monitoring? Thank you very much for your input here. So just briefly, what is the difference between risk-based quality management and centralized statistical monitoring? For the RBQM process with the key risk indicators and the QTLs, you need to identify the critical data and the critical processes. So that is a step that you do not do in the centralized statistical monitoring exercise. You do also do a risk scoring. So you look into the impact probability and detectability, something that you do not have to do for centralized statistical monitoring. You identify mitigation actions. Now, at least initially, you don't do that for centralized statistical monitoring. Eventually, you may have to do that, and we'll get into that particular situation later in our presentation. And for RBQM, definition of key risk indicators and quality tolerance limits, that's something that you also don't need to do for centralized statistical monitoring. However, CSM requires a couple of things. You need numeric data. You also need to have people in your organization that understand the relationship between and amongst the data, because CSM is really using the data that are available and comparing all these various types of data against each other, at least if that is what you want to do. And we'll, as I said, I'll provide you with some examples. And one needs some natural science background, because you need to have an understanding of what is, for instance, cardiac output, or what is a stroke volume, or what is a blood pressure, systolic and a diastolic blood pressure, what is hemoglobin, what are reticulocytes, and so on and so forth. So to really be able to use CSM properly, you need to have some natural science background. So what is CSM? I have 4 bullet points here that I want to briefly go through with you. So centralized statistical monitoring is a process that combines clinical monitoring with the exploration of statistical parameters of variables. So this is not about just looking at certain items exceeding a threshold or exceeding a certain percentage, but this is really looking into these data and running clinical monitoring using statistical parameters. Now, what I can already see is a panic mode. At least that is something that I applied in my previous life. Whenever I saw statistical parameters, I thought, okay, that's for the statisticians, and I stepped out of this exercise. But in the last 5, 10, 15 years, the situation improved drastically. And I don't want to say whatever statisticians can do is something that also others can do. At least a lot of the data can be looked at using statistical parameters, and those can then also be understood by someone who is not a statistician or a statistical programmer. The centralized monitoring is when the site data is evaluated for risk in real life or real time from a single off-site location, rather than reviewing risk directly on site at each investigative site. Now, in reality, reviewing risks directly as a site monitor at the site is almost impossible, because you have really a limited view. You pretty much look at one patient at a time. You do not have an overview as a site monitor of what's going on at the site. So therefore, implementing a centralized monitoring functionality, staff or organization within an organization makes a lot of sense, because those are individuals then that look across the sites, or maybe also within a site, from a bird's eye view on what is it that goes wrong at those sites and how site number 1 compares to site number 2. So therefore, a centralized monitoring is certainly a good way forward, and probably the best way forward these days. Statistical monitoring, just to break down this term, centralized statistical monitoring. Statistical monitoring is the review of the data via complex statistical algorithms recommended by Transcelerate. Transcelerate is an organization that put together a lot of common processes in our industry. And one of the processes and one of the topics that they addressed is risk-based quality management, and is also centralized statistical monitoring. So this organization recommended statistical algorithms to discover data outliers and anomalies, the result of which will inform the user about various monitoring recommendations and escalation options. So the various monitoring recommendations means that a central monitor that looks at CSM data may see things that warrants a site monitor to go to the site more frequently, or to put focus on certain aspects at the sites, like equipment for blood pressure measurement, or the way how they take blood samples and put them into the fridge, or maybe not put them not into the fridge. And therefore, centralized statistical monitoring is also helping the site monitoring. And CSM offers a single comprehensive overview for efficient cross-functional collaboration during the clinical trial process. CSM is not only looking into aspects that are important for the sites or for the site monitors, but could also be very helpful for instance, clinical data managers, could be something for pharmacovigilance to take a closer look at, could be of interest to the project manager because some things could be seen in the CSM analysis output that nobody expected and therefore may have an impact on the overall development of a compound. So just a brief explanation of what CSM is. So a couple of basic requirements. The first step when you start implementing CSM is that you need to identify data sources. 20 years ago, the data source was pretty much a paper-based database, maybe SAS, maybe SQL. Nowadays, we have usually a lot of different data sources. So we hopefully, for the most part, have data that originate from electronic data capture. But I see in many, many studies also the implementation of eCOA or ePro data that might be of interest for CSM. Many organizations use central lab data, and if those central lab data are being captured, they do not necessarily end up in the EDC system, but could be transferred, for instance, into something like a data lake or a study database, but outside of the EDC system. So the first 3 bullet points already provide you with 3 different types of data sources. And these are only examples because you may have data from a central ECG provider, you may have data that originate from the pharmacokinetics bioanalytics organization, so may come in different database. So there are lots of different data sources, and you need to understand what is it that I want to do with CSM and which of these different data sources are of interest. The next question is, are the data all structured in the same format? One would expect that 2 studies in an organization use the same data structure, but in real life, that is not necessarily the case. I've seen studies that had almost the same protocol, but the data structure that the CROs used were 2 different ones. So that's important to get at least an understanding of what is the data structure for my study that is of interest. And then, as I mentioned, is there a data lake, a data pool, a data warehouse that can be used as a data source? Of course, it makes life much, much easier if you have such a data lake or a data warehouse where all your studies are stored and are stored in the same structure. But that might not necessarily be the case for all organizations that want to implement CSM. Are there any other external data that are of interest? So sometimes there are special labs, that analyze data that are not part of the safety lab that the central labs usually analyze, and those data may also be of interest. And this is probably the audit trail data are available and accessible. This is maybe something for the advanced users. So once you covered all the bullet points above and you feel bored or you implemented everything properly, then you may take the next step and look into the audit trail data. I'm saying that because usually the audit trail data are huge. It's a huge volume of data, and analyzing those may require, again, additional resources and also an understanding of what you may find or may not find in the audit trail. So let's do another brainstorming session. This is the first brainstorming, but an exercise with you.
Yes. And the tool is open now. As already said, just click on the icon with the cups and the pens on the T, and you can start writing. What is the purpose of conducting a series of numeric data analysis? What do you think?
So why would you implement centralized statistical monitoring for numeric data in the first place? What is your expectation?
So I'm also receiving answers here in the chat window. One participant is saying develop predictive models.
Mm-hmm. That's already advanced. Yeah, okay. Yeah, maybe I can already start commenting upon what I see here. So one of the expectations, and that's a valid expectation, is find outliers, find deviations, find anomalies in the data. And these anomalies, these deviations could be, or not necessarily, but could be risks for the study. And therefore, CSM is certainly a good way of potentially identifying those additional risks that you did not consider during your RBQM, KRI, QTL implementation exercise. Also trending. I see this twice here, to identify trends and identify for trending purposes. So these two comments, definitely valid comments, because what you sometimes see is that over time, situation improves, or sometimes over time you all of a sudden see that something does not run as expected. Um, so for trending purposes, I recall a situation where we used two different labs for biomarker analyses. And these two different labs were from the same organization, but they were in two different locations. One was in Europe, and the other one was in Asia Pacific. And what you could see there is that there were two different sort of curves available from these two different labs for the concentration of certain biomarkers. And that was not dependent on race or any other criteria, but it was really the way how the lab managed the samples. That is certainly something that you can identify there. And discover fraud, that's asking for a lot, but definitely the centralized statistical monitoring can also help you in identifying fraud. Okay, thank you very much. That was already quite good. So then let's move on. So what type of methods are available? And we will not be able to go through all the different methods that CSM offers, because there are certainly hundreds, but at least walk you through the basic ones, the ones that are usually helpful for each and every user, and that provide you already probably in 98% of the cases with a good understanding of what's going on in my study. Are there any issues in my study that I should then address later on? So there are algorithms available that produce, for instance, histograms, scatter plots, interquartile ranges, correlation diagrams, Benford's law, and I think you will, go through all these examples with you, and potentially heat maps that could identify sites or patients. Depends on how you implement CSM, that are different from all the others. Detection, and I think this is what we also saw already during the during the brainstorming session, are the outliers. Look into and find data anomalies, find skewed data distributions, find bimodal distributions or multiple modal distributions, differences between labs, and this is the example that I just gave, where you use a central lab with two different locations, and all of a sudden, these two different labs deliver two different types of data. Identify sloppiness, so sort of working backwards from the fraud example, the fraud brainstorming proposal, but sloppiness is already something that could be identified. Fabricated data, and fabricated data are probably very close to fraud. And when you have fraudulent data, then you want to certainly make sure that you identify those. And data correction patterns via the audit trail. So which are the data fields that are being modified once at least or multiple times in your study, so that you identify fields, data fields that obviously need a lot of correction by those that enter the data into the EDC system, for instance, in the first place. So just to start with a couple of examples. So the first one is looking into outliers. So what you can see here on the left-hand side, you have the data for echocardiography, cardiac output, and here you have the stroke volume. And what you see here, maybe you cannot see it, but trust me, there is a data point here, up here, with a cardiac output of 53 liters per minute. Now we are talking about human beings, and humans usually have a cardiac output of about 5, 3, 4, maybe 6 liters. So this curve here at the bottom, or this line at the bottom, is what you could expect. 53 liters could be sloppiness, forgetting to enter the comma after the 5. And once those data had been corrected, then this value would fall into this category of 5.3 liters. And you have another case here. You have 0 cardiac output. Now there are two options. Either this is a data entry error. It could also mean that the data are not available, or that the patient died already. I think in this case, it's probably just a mistake, or an indicator. Sorry, I don't have the I don't have the cardiac output values available. But you can also see, that you have stroke volumes of up to 100, almost 100 milliliter, which means, which every beat, the heart pumps about 100 milliliters. By the way, that's a lot, because someone with 100 milliliters and a heartbeat or heart rate of about 60 pumps already 6 liters. And that's usually a healthy person, and not necessarily someone that is sick and maybe should not be in your study. So this is an example of looking at outliers, something that you are probably aware of. Now, this is a slightly different example with data anomalies. And here on the left-hand side, you have the left ventricular systolic diameter, and at the bottom, you have the left ventricular diastolic diameter. And the diastolic should always be bigger than the systolic, because the systolic means that the heart just started pumping, and the diastolic is the heart relaxed. What you see here, there are a couple of cases that really have very, very low systolic as well as diastolic diameters. And, someone may want to take a closer look at what are these patients. I mean, are they seriously ill, or is this a measurement problem, or what is this? And on the other hand, you have this right upper corner case where you have left ventricular diameters of greater than 7, but they are very close to the systolic, which means that hardly anything happens in the heart between the systole and the diastole. Okay. So data anomalies that someone wants to take a look at. And you may also consider those that I did not highlight here, but those two values here at the bottom, for instance. And this is another one. Obviously, I like stroke volume and I like the cardiac output. So this is, again, the cardiac output on the y-axis and the stroke volume on the x-axis. And you see there are patients with a low cardiac output. Those are these patients. And you have patients with a low stroke volume. Those are the ones within that red circle. And those may be the patient, and this is, of course, taking it to the extremes, but those are the patients that someone may want to take a closer look at, and whether the circle, has to be as big as this one or this blue one is debatable. You can make it much smaller, but these are the cases that are usually in question. And with these three examples, I pass it on to Ting Yu, who is going to walk you through the next couple of examples.
Thank you, Johan. Yeah. So as Johan mentioned in the previous slide, so beside those outlier detection method, there's other data anomalies that you should be aware of while doing centralized statistics monitoring. So the next one is the shape of the distribution. Usually values of, for example, hormone concentration, vital signs are normal distributed. So as we shown above here, it's a bell shape. However, in some cases, in some studies, if we visualize the numeric data, we'll see the skewed normal distribution, like this one below. And the reason of skewness could be very complex, but most of the cases appear to be very dependent on the sample size. So regarding the distribution, there is another possibility that we might see through the histogram, which is bimodule or multi-module distribution. Here we take hemoglobin as an example. So for males, hemoglobin values are mainly between 14.4 to 16.6 gram per deciliter. But for female, the value is a bit lower, between 12.7 to 14.7 gram per deciliter. Therefore, if we visualize the value by histogram, we will expect to see a bimodule distribution here, which with two peaks. In this example, this bimodule is composed of two distributions, and each of them stay in a bell shape, but might overlap each other in a certain range, which we have in real data example in the following slide. And this bimodule distribution was resulted from a physiological reason, but for unstandardized unit, issue can also lead to this kind of distribution, which we also have a real example for you in the later slide. And if that is the issue, like this bimodal distribution was resulted from an unstandardized unit, then probably a center monitor should pay attention to it. Yeah, so this example is the same using hemoglobin value, but this time the distribution are widely apart from each other, which is this bar, and this looks like a normal distribution here. And the reason for this is that the labs in this study are using different units when they measure the value. So there are totally 3 different units being used here, which is the millimole per liter, gram per liter, and gram per deciliter. So under this scenario, the center monitor cannot identify the outlier with this histogram because the data here in this bar are all aggregated together, and it's very hard to identify the minimum value or any other anomalies. So we convert all the units that we mentioned, those 3 different units, into gram per deciliter, which is the standardized unit written in the protocol. So as you can see, the bimodal distribution is back with these two peaks together. And by the way, this study is an oncology study, so you might notice the value is slightly different from what we introduced you in the previous slide. So the benefit of this is that the central monitor now can identify the possible outlier better with the minimum value here. So there are subject who has hemoglobin only 4.6 gram per deciliter, which requires further investigation if you found this issue. Yes, so after talking about some general distribution, like the shape of it, and checking the bimodule distribution or multi-module distribution, there's another method which we can look into the trail digit distribution and try to figure out the stubbornness and fraud data as someone talked about, as like you provide in the discussion section, that CSM function might be available to detect the fraud. So this method is commonly used in vital sign data, such as heart rate. So we prepare the example from the heart rate data here. And the blue bar shows the last two-digit distribution for all heart rate value in this study. And the orange curve displays the same distribution from one of the sites in the study. So you might have already noticed that the pattern in the orange curve. So all the last two-digit value from this site are multiples of 4. Since the administrator probably didn't follow the protocol, which the measurement of heart rate should take 8 minutes. Instead, they measure the heart rate for only 15 seconds and multiply the value directly by 4 to get the beats per minute. That's why we can observe this pattern through the data visualization. And as you can see, this is definitely a potential protocol deviation risk, which we should be aware of. Yeah. So after seeing some CSM findings, we would definitely like to know what action should be taken when those issue takes place. First, we can create ticket and send site monitor to the site to check. And second, as we've shown in the previous examples, that labs are using different units, we might ask center lab to check their process to see if they follows the protocol, or the data manager can do the same thing as we did for the conversion, like converting the different unit into one standardized. And at the same time, the medical monitor should be alert about the cases. So the same idea here as an example of heart rate measurement, which is probably a protocol deviation risk. So better to add this risk to the risk library. And last but not least, can think about sending the auditor to the site if that is required. Yeah, so I'll hand it over to Tamara for the Q&A section.
Yes, thank you very much. So, dear participants, if there is anything you would like to ask Ting Yu or Johan, just put your question here in the chat window, please. But if I'm not mistaken, Johan, there is something more that you wanted to tell our audience, right?
Yes, actually, I wanted to elaborate on what we showed here as sort of the first set of examples. Actually, these examples look pretty simple and straightforward, and we did that on purpose. But using CSM can get really, really complicated. And if you really start using all of your, or a lot of your numeric data that you have available, just like central lab data, hematology, clinical chemistry, urinalysis data, then if you compare then all data with all other data, it can really, really produce a huge output. So I'm personally still struggling with should we limit ourselves to certain analyses, or should we just take a system and run the system against all the numeric data that we have? As I said, sometimes it may be difficult to interpret then the outcome. On the other hand, it may reveal all of a sudden relationships of data that you never ever expected, and that may not be expected because physiologically they do not belong together. But there seems to be a relationship that the investigator at a particular site created. And those, of course, are the ones where we should get a little suspicious about, what does that mean for that site? Are they fabricating the data, or is that something that is due to the patient population that this site enrolled? Or should we go the other way around and limit the CSM to data that we already know they are related to each other? Making up this example, red blood cells on one hand and the hemoglobin on the other hand. But maybe the truth is somewhere in between. But I see that there is a first question. Would histogram, for example, of HRM show fraud in case less patients were enrolled than displayed and data of that patient copied and multiplied? Maybe you have an example. Actually, yes, we have seen examples, not necessarily via the histogram, but I have seen examples where a site duplicated a patient, and that, luckily enough, was a patient that had already extreme values. So the extreme values had been put out by the CSM, and then the same record or a set of records showed up twice. And when you look at the data and you get identical records a couple of times, then this cannot be. This is something that is definitely a case for taking a closer look at. In particular, when these records are from two different patients, or fake two different patients. So I'm not 100% sure I understand what HRM is. Maybe the person that asked that question can explain what HRM is. Maybe we can clarify that. Heart rate measure. Okay, I see what you mean. So would a histogram of the heart rate measure show fraud in case less patients were enrolled than displayed? Yes, definitely. Definitely, one could still see that. We do not only see that for heart rate, we see that frequently also for systolic and diastolic blood pressure measurements. And I think what CSM could also be used for, and I think you and we didn't show that, is really looking for duplicate records. Duplicate records, for instance, within the vital signs area. Duplicate records are also good candidates for ECG findings. If these ECG measurements had not been produced by a central lab, and you all of a sudden see duplicate records, then that's suspicious. And we see that sometimes also in the area of lab data, not so much in the area of hematology and clinical chemistry, but urinalysis data. Urinalysis data also seem to be subject to modifying data and creating fake data.
So maybe I can add something here, like the example we showed with that trail digit, or maybe you check the head digit, that can still show some duplicates. Even the amount of data is not really huge. since it is comparing between site by site. So like it still can show some anomaly or sloppiness on that site if that site is really duplicating the data.
Okay, thank you very much. Is there anything else that you guys want to know from us? Okay. No further question, I guess. Everything was addressed. That's great. But for your information, I'm also sent you the recording of this webinar. So, and maybe there is a question coming up later when you watch that recording here. And in that case, then feel free to contact us at academy@syntegrity.com. I just put in my email address here into the chat window. All right. Thank you all very much. It was nice to have you here in this webinar. We have now reached the end of the workshop. And as I said, tomorrow I'm going to send you a follow-up email with the access to the recording and also to the slide deck. Yeah, we hope you found this workshop informative and would be our pleasure to welcome you again to our next mindsON CSM session. That is again how to use the Centralized Statistical Monitoring tool. We will continue with that on Wednesday.